Question 1 tells us that 31% are Democrats of this town. So if you select two people at random and they ask, what's the probability that both are Democrat? Well, that means that the first is Democrat, and it means also that the second is Democrat, which is 0.31 times 0.31, or simply 0.31 to the second power. Point 0.31 raised to the second power is 0.961. If we approximate this answer to the nearest thousandths, the 6 is in the thousandths position, which means the 1 does not change the 6 value. The answer is 0.096. Question 3. Probability that you will accept the yield is 0.7. That means 70% is selected or accepted here. So if you select 3, what's the probability that all will be accepted? Well, that means that the first is accepted and the second is accepted and the third is accepted, which means 0.7 times 0.7 times 0.7 are simply 0.7 to the third power. The answer is approximately 0.343. Question 5. A bag has 77 bulbs, in which 10 are defective. That implies that 67 of the bulbs are okay. So if we select 5 bulbs, the probability that they're all okay means that the first is okay, the second is okay, the third, the fourth, and the fifth is okay. 67 over 77 times 67 over 77, I have 5 of these fractions, which is 67 over 77 to the 5th power. If I approximate this answer to the nearest thousandths, 67 divided by 77, raise this to the 5th power. The 8 is in the thousandths position. The 7 says add 1 to the 8 for a 9. The answer is 0.499. Question 7. The probability that a graduate finds a job is 0.52. So you're now going to select 9. The probability they all find jobs, since we're selecting 9, is 0.52 to the 9th power. .52 raised to the 9th power. If we approximate this answer to the nearest thousandths, the 2 is in the thousandths position. The 7 says add 1 to the 2 for a 3. The answer is 0.003. Question 9. You're going to select 2 cards from a standard deck without replacement. 2 cards without replacement. What's the probability they are both black? Well, that means the first had to be black, and it means the second had to be black. So we reach in the card, or reach in a deck. Probably the first is black. There's 26 cards that are black out of 52 cards. Since this is without replacement, that first card we selected is thrown out the window, meaning the probability that the second card is black, while there's 25 black cards now that are left out of the 51 cards that are left. So if we approximate this answer to the nearest thousandths, we'll get this value, where a 5 here is in the thousandths position. The digit to the right is a 0. Do not add 1 to the 5. The answer is 0.245. Question 11. You were selecting 4 people, and you want to determine the probability they all have different birthdays. Now, the first person can be born on any day of the year. That is, the first person has 365 days they could have been born on out of the 365 days that are in a year. The second person has one less option, meaning if the first was born, say, on June 1st, the second person has to not be born on June 1st. The second person can be born on any of the 364 days out of the 365 days in a year. Similarly, the third person has even less options, 2 less options to be exact. 363 days out of 365. The fourth person can be born on any of the 362 remaining days out of 365 days. Now, to determine this probability, we have to multiply these 4 fractions together, and then we'll approximate the answer to the nearest thousandths. Note that this first fraction, 365 over 365, is 1. This will help in minimizing the amount of work we have to do. 364 times 363 times 362 divided by 365 raised to the 3rd power. If we approximate this number to the nearest thousandths, the answer is 0.984, because the 6 to the right of the digit that's in the thousandths position, the 3, indicates we have to add 1 to 3, 0.984. We're going to select 4 different calculators from this batch. Select 4 different calculators. Now the batch has 45 defective, 27 non-defective, for a total of 72 calculators. Probability all four are defective. Probability all four are defective. That means the first is defective times the second being defective times the third being defective times the fourth being defective. Four fractions. So, if we reach in the bag, the probability that the first calculator is defective is 45 out of 72. There's 45 defective calculators out of the batch of 72. Now, all four being different means this is without replacement. We could not put a calculator back in the bag and select that calculator possibly again. So, when I reach in the bag and I select a defective calculator, the probability that the second calculator is defective will now be 44 over 71. This is without replacement. They have to be different. The probability the third is defective, 43 out of 70. Then finally the fourth will be 42 out of 69. So if I got to approximate this answer to the nearest thousandths using my calculator, 45 times 44 times 43 times 42 divided by 72 times 71 times 70 times 69. If we approximate this answer to the nearest thousandths, the second 4 is in the thousands position. The digit to the right is an 8, which means I add 1 to the second 4 for a value of 0.145. Question 15. You're going to select two different people. Remember, selecting two different people is equivalent to saying you're going to sample without replacement. They want to know what's the probability that both are women. That means the first is a woman and the second is a woman. Now, there are 393 women out of 911 people in the table. Since they both have to be different, when you select that first person and it's a woman, again, remember you were throwing that person out the window. So there's now 392 women left out of 910 people. This is without replacement. The people need to be different. So if I multiply these two fractions together and I approximate my answer to the nearest thousandths, let's see what I get. The 5 is in the thousands position. The digit to the right is an 8, which means add 1 to the 5 for an answer of 0.186. Question 17 says you are to select 8 people. It's a probability they all probability that any one of them has a job is 0.57. They're asking what's the probability from the 8 that at least one will have a job. That's 1 minus the probability that none will have a job. Now, the probability that someone finds a job is 0.57. The probability of not finding a job is the complement, which will be 1 minus that 0.57, which is 0.43. This is what we're going to use. So that the probability that at least one person finds a job is 1 minus 0.43. However, we are selecting 8 people. So this fraction here, or this probability value, is 0.43 to the 8th power. If I were to enter this information in my calculator, 1 minus 0.43 raised to the 8th power, I'm going to get 0.99883. If I approximate this answer to the nearest thousandths, the 8 is in the thousandths position. The digit to the right is another 8, meaning I add 1 to the 8 for a 9. This is 0.999. The key here is we're going to need to use the multiplication rule for this probability. Since we're selecting 8 people, this is 0.43 to the 8th power. Question 19. 8,000 clock radios. In question 19, 7% are defective. So 7% of 8,000 is 0.07 times 8,000 is 560. 560 are defective. Now, when they purchase a batch of radios, a batch is rejected, okay, if at least one clock is defective when they select 6 clocks. So they're going to select 6 clock radios here, and if at least one is defective, then they will reject the batch. Okay? If at least one is rejective of the 6 that they select, they reject the batch. Now, the question is, what's the probability that they reject the batch? That's equivalent to determining the probability that at least one of those clock radios is defective, which is 1 minus the probability that none are defective. Now again here, this is where all your work's going to be, because none being defective means that the first is not defective, the second is not defective, all the way up to the 6th not being defective. This is the probabilities that we have to determine and compute to answer the overall question. Now these probabilities here in blue, okay, are found by doing the following. Since we know from the prior information that 560 are defective out of the 8,000, What that means is 8,000 minus the 560 is 7,440 that are okay. So 7,440 are okay, while 560 are defective out of the 8,000. So the probability that the first is not defective, that's equivalent to being okay. So you're determining all of those probabilities are being okay. None are defective. So that's going to be 7,440 divided by the 8,000. Now I have 6 of these probabilities. So if I want to look at this in more detail, the probability that it's rejected, at least one is defective, be 1 minus 7,440 over the 8,000 times 7,439 over the 8,000. This is without replacement. 7,438 over, without replacement, 7,999, 7,998 times 7,437 over 7,997 times two additional fractions here, 7,436, 7,996, 7,435, 7,995. Let's put this in our calculator and see what we get. 1 minus 7,440 times 7,439 times 7,438 times 7,437 times 4,036 times 4,035 divided by 8,000 times 7,999 times 7,998 times 7,997 times 7,996 times 7,995. If we approximate this answer to the nearest thousandths, the 3 is in the thousandths position. The digit to the right is a 1, which means we do not add 1 to 3. The answer is 0.353. This is the probability that at least one of the 6 alarm clocks are defective, or the probability of rejecting the batch.